Example 5 has y equals 3 times log base 1/2 of x, okay? So remember, we have y equals, your a is always going to be in the front, and then your log, your subscript is always going to be your base. You have x minus h in the parentheses. Now, if we do not have any minuses with the x or addition behind the parentheses, that means the h and the k are both going to be 0. So your a is going to be in the front, which is 3. Oops, I meant to say 3. And h and k are both going to be 0. Your base is 2, so your parent equation is y equals log, your base is a half, I'm sorry, my apologies, your base is a half, so y equals log base half, as soon as my computer, there you go, log base half of x. Come on, computer. Log base half of x, okay? Now, we do want to write it as an equivalent equation in exponential. Equivalent expo. Start with your base, okay? So your base is a half to a y exponent equals x. So this means your y is your input, so we are going to choose y to put into the equation. That's why it's called input. So we have 1/2 is your base to a negative exponent. If you guys remember, if it's a negative exponent, we flip this to a 2 and make the exponent positive, so this comes out to be 4. And same thing, guys, 1/2 to the negative 1/2 is your base to a negative 1. It becomes 2 to the first, which is 2. 1/2 to the 0 is 1. 1/2 to the first power is a half, and 1/2 square, like that, is now a 4th. Okay. So here are your 5 parent and x values, and then these are your 5 y values. Okay. Now we have a is 3, so what that meant is that we have 3 times y. We don't change x at all because we don't have an h value. So your x will stay exactly the same as your parent function, but the y values, we are going to multiply that by 3. So negative 2 times 3 is negative 6, negative 1 times 3 is negative 3, 0 times 3 is 0, 1 times 3 is 3, and then 2 times 3 is 6. Okay. Remember, we have an asymptote, a vertical asymptote on x equal to 0. Since we don't have any h value, it's still at h equals to 0. So positive 4 go to negative 6, and then we get 2 is negative 3, 1 is 0, 1/2 is 3, and 1/4 is 6. So this is vertically stretching by 3 times. Okay, so that's why it looks a little bit more vertically. Okay, so we only have one transformation, vertical stretch factor of 3. H and k is 0, 0. X intercept, we do have one, okay, at 1, 0. Y intercept, none, because we are not touching the y asymptote since we have, so we're not touching the y-axis since the asymptote is there. Your domain is going to be from 0 to infinity, or x is bigger than 0. Your range is all real numbers, or you can write it as an interval notation. It is decreasing over the entire domain. It is definitely 1-to-1. And yes, we have a vertical asymptote at x equals to 0. Example 6 says f of x equals log base 6 of x plus 4, close the parentheses, plus 3. So because there's a number 1 right there in the front, so your a is 1, your h is negative 4, and your k is positive 3. Your base is 6, okay? Base is 6. So your parent equation is y equals log subscript 6 of x. Now remember, we want to write it in equivalent equation. Equivalent exponential equation, okay? Since the base is 6, we write 6 to the y power equals x. Remember, in this form, your y is the input, so we are going to choose all of your y values. And let's plug it in. 6 to the negative 2, guys, is 1 over 36. 6 to the negative 1 is 1 over 6. 6 to the 0 is 1. 6 to the first power is 6. 6 to the second power is 36. Now, since your a, h, and k, your a is 1, so 1 times y doesn't change, but we are going to add 3, okay, because your k. Your x is going to be minus 4, and then now take a minute, guys, to change your transformation table. So 1 over 36, students, take away 4 is now negative 3, and then we got the remainder of 35 over 36. 1/6 minus 4 is now negative 3 and 5 over 6. 1 minus 4 is negative 3. 6 minus 4 is positive 2. 36 minus 4 is 32. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Remember, we normally have a vertical asymptote at x equals to 0, but because we are shifting left by 4, so now we would have a vertical asymptote at x equals to 4. I'm sorry, negative 4. All right, let's plot. Negative 3 and 35 over 36, guys, is super close to negative 4, but not quite. So I'm going to go up 1. Okay, super close to the asymptote. Negative 3, 5 over 6 is super close to the asymptote still. Going up 2. Negative 3, go up 3, super close. Now positive 2, go up to 4. And then 32, go up 5. I don't have 32, so I'm just going to leave that last dot out. Okay, guys, so let's connect these dots. Whoops, come on, computer. Come on, computer, let's work. No? Okay, let's try to see if this works. Okay, that's better now. Okay, make sure we get really close to the asymptote. Go all the way through the grid. Have arrows on both sides, okay? We do have 2 transformations, so let's go and write those out. We have an h value being negative 4, guys, so left 4 units. And then we have a k value of 3, so we're going to go up 3 units. Okay, let's quickly fill out the h and k. Negative 4, comma 3. X-intercept, it does cross, so we're going to have to wait and solve that manually. We also have a y-intercept, so let's wait and solve for that as well. Then the domain is going to be from negative 4 to infinity. Your range is all real. This time it is increasing over your domain. It is definitely a 1-to-1. We have a vertical asymptote, guys, at x equals to negative 4. It looks like my graph got shifted a little bit here because my computer wasn't working, but we know that was earlier. Let me just see if I can move it back because it looks super weird right now. Will it let me move back, guys? Let's try. Come on. Oh my gosh. Let's just move way back there. Come on. Ooh, there you go. Ooh, that's a little bit better. Okay, so now remember, we can't really eyeball the x-intercept and the y-intercept. So let's solve for it. X-intercept, guys, is when y equals to 0. Okay, 0 equals log base 6 of x plus 4 and then plus 3. Remember, your goal is to isolate your log first. So subtract 3 to both sides. So negative 3 equals log base 6 of x plus 4. because we only have one log in this equation, now we have to rewrite it in exponential form. So 6 to the negative 3 equals x plus 4. Well, we don't want negative exponents, so let's make it a positive exponent by moving it in the denominator, right? So 1 over 6 to the third. Now 6 to the third, guys, is 216, okay? So it's 1 over 216. The last piece here is to subtract 4 to both sides. So we have x is 1 over 216, take away 4, so that's going to be a negative 3, and then 215 over 216. So that's your x intercept. Write it in. Negative 3, 215 over 216, comma 0. Now the y-intercept, we are going to do similar, but this time we are going to let x be 0. So y-int x equals to 0. So that's going to say y equals log base 6 of 0 plus 4 is going to be 4, and then plus 3. Your exact form is going to say log 4 divided by log 6 plus 3. So this is your exact form, okay? Now I'm going to see if you can give that to me in decimal approximation to 2 decimal places. Okay, so guys, I hope you guys have about 3.77, okay? So have both, just in case. Okay, so y-intercept x equal to 0, so 0, comma, log 4 divided by log 6 plus 3. That's if we want exact. Now if we want approximation, then it's 0, comma, 3.77.